Welcome to Module 2, the evolution of building automation. In this lesson, we will look at how building controls developed from manual and local operation to pneumatic systems, electronic controls, DDC, open protocols, IP networks, smart buildings, and AI-assisted operations. The main point is simple. Every generation solves old limitations and creates new responsibilities. By the end of this module, you will be able to describe the main stages in building automation history and explain what each stage changed. We will also study why open protocols and IP networking transformed the profession, why smart does not always mean mature, and why modernization must include technology, process, people, and governance. The history of building automation can be understood as a progression toward greater consistency, visibility, scale, interoperability, and predictive capability. But progress also creates dependencies. Better technology does not remove the need for engineering judgment. In fact, the more connected the system becomes, the more important judgment, documentation, and governance become. This timeline shows the major stages. Manual operation relied on human observation, pneumatic systems provided automatic analog regulation, electronic controls improved sensing and signaling, DDC made logic programmable, networked buildings created integration and scale, smart buildings added analytics and dashboards, intelligent buildings use AI-assisted methods. For each stage, ask two questions: what capability did we gain, and what risk or responsibility came with it? Manual systems were labor-intensive, but experienced operators often understood the physical system deeply. They knew how equipment sounded, how spaces responded in weather, and how systems behaved seasonally. The weakness was that knowledge was local and personal. The management lesson is not to return to manual operation. The lesson is to preserve physical understanding even in modern connected systems. Pneumatic controls introduced automatic regulation using compressed air. They established many concepts that we still use today: proportional response, reset, sequencing, averaging, high and low selection, and fail-safe actuator behavior. Many pneumatic systems lasted for decades, but they also created challenges: leaks, calibration, limited remote diagnostics, and limited data. During modernization, we must understand the original control intent before replacing hardware. Electronic controls improved sensing and signaling. Direct digital control then made control logic programmable. This changed everything. A workstation could supervise many systems, store trends, route alarms, and modify logic. The same capability also introduced new dependencies: software versions, program quality, database integrity, backups, access rights, and tools. The professional rule is clear: fast change requires disciplined change control. Networked buildings required devices to exchange information. Open protocols such as BACnet improved integration and choice, but open does not mean automatic. Successful interoperability still requires compatible object and service support, clear point ownership, unique addressing, correct units and scaling, security architecture, testing, documentation, and long-term support. A system can use an open protocol and still be difficult to maintain. Ethernet and IP networking connected BAS to enterprise technology. That expanded capability but changed risk. BAS is no longer isolated controls infrastructure. It is part of an organizational cyber-physical environment. Smart buildings use connected systems and reliable information to improve decisions. Intelligent buildings may use anomaly detection, predictive maintenance, optimization, natural language interfaces, or digital twins. These capabilities increase the importance of governance, data quality, cybersecurity, and human accountability. A modernization project may replace controllers, servers, networks, or software, but the real opportunity is to improve the operating model. A complete modernization reviews technology, process, people, and governance. If we replace the front end but keep poor naming, uncontrolled alarms, undocumented changes, and weak training, we have not solved the main problem. We only moved the problem into a new platform. This table is a management tool. Each generation brought capability and risk. Manual systems preserved physical understanding but depended on individuals. Pneumatic systems provided stable regulation but needed maintenance discipline. DDC added programmability but required backups and change control. Networked systems created integration but required architecture governance. Smart and AI-assisted systems can accelerate insight, but they require reliable data, human accountability, and safe fallback. To complete this module, perform a 4-dimension modernization review. Choose a facility scenario and evaluate technology, process, people, and governance. Then identify the first 3 actions that should happen before the project becomes a hardware replacement. Remember the principle of this chapter. Every generation of automation solves old limitations and creates new responsibilities. In the next module, we will study buildings as cyber-physical systems.